Hi, good morning, good afternoon, and good evening, everyone, depending on where you are joining us from today. So, hi, Håkan. Hi, Jean-Pierre. Actually, JP, right?
Yes, please.
So, how are you, JP? How do you feel today?
I am excited and
That's good
nervous.
to hear.
Yeah. And
You shouldn't be
too.
nervous.
We are
So, go
very
ahead,
excited,
Håkan,
and
sorry.
we can actually see here from some of our viewers that they are also excited for this episode. So that sounds very great. Actually, where are you streaming from, JP?
I am streaming from Pretoria, South Africa.
Oh, nice.
Yes, nice weather, rainy weather today.
Yes.
But otherwise, it must be much warmer than here in Scandinavia, I guess.
I believe so. I also have been told.
Yeah. All right. So today we are here because we came back with an awesome session of AI 42. And we are going to, not we, but JP is going to tell you about Transact SQL. JP, would you like to say a few words why this session is going to be very important for us going forward when going on the path to become data scientists and AI engineers?
Yes, of course. So T-SQL is one of the most widely used SQL derivatives. So there's a couple of different SQL derivatives out there. T-SQL, PL/SQL is a couple of different, but T-SQL is one of your more popular ones. And basic data manipulation and working with your initial process of starting to work with your data is generally a good place to start when you start in T-SQL. After you've prepared the majority of your data, that's when you go and do all the smart and fancy stuff in your AI once your data has already been prepared. And T-SQL is one of the easiest, most effective, and fastest ways of getting that done.
Yeah, that sounds exciting, really. Okay, so what do you guys think? Shall we get into the middle of it and get started? Get started first with introducing AI 42, and then continue with JP's awesome session.
Yes.
Yeah.
Hi, and welcome back again, everyone. So let us say a few words about what is AI 42. So the motivation for starting AI 42 comes from the recognition that there is no good starting material. And we aim to take all the way from complete beginner to getting enough knowledge to be able to build your own models. So we hope you will enjoy this journey with us. So Håkan, would you like to tell a few words about what is our concept?
Yeah, so basically, as Eve said here, we want to take you from complete beginners so that to the way that you can start out as a data scientist. So the way that we will do it is we will stream 2 times a month on Wednesdays, and then we've invited in recognized speakers and industry experts that will talk about and teach us in the topic in their field. So as some of you may know, we have started with 5 sessions here on mathematics with Heine Ilmarinen, and now we go more into different languages and tools that can be very useful for a data scientist. So today we are starting with JP, who will teach us about T-SQL, and then after that we will talk about, for example, Python and R and Scala, and then we will talk more about machine learning and more advanced topics like reinforcement learning and deep learning and so on.
Yes, and as Håkan already mentioned, you will be able to connect with the best-in-class experts from all around the world, and they will hold you these different lectures and workshops also with very rich content. And we also create close collaboration with other organizations as well. And that also gives you a very good opportunity to broaden your network in the AI and data science communities. And if you want to follow us and join us in this movement and to learn more in the coming weeks and months. Please go on and follow us on Instagram, Twitter, and Facebook. And you can find our recorded videos on YouTube. And about the next sessions that are coming up, you can find information on our meetup page.
And we would also like to take the time here to thank our sponsors. So we're sponsored by Microsoft and Miles. And then, as Eve said, we also are in collaboration both with the global AI community, with the C# Corner, and we have our intro music is composed and performed by Mina Marie, and all of the graphic design that you can see here on our stream is by Levente Pongor.
And with that, we would like to invite you to be part of this community, to help to learn more about what is data science, what is AI, how can you become a very strong and responsible data scientist and AI engineer. Shall we get started?
Yeah, let's get back to JP here. So JP, maybe you can tell us a little bit more about what you will be showing us and teaching us tonight.
Okay, so my name is JP Vught. I'm a South African data engineer, and what I want to do tonight is I want to give you a well-rounded introduction into T-SQL to prepare you for all the following sessions in, like was discussed earlier, your different models and all of those nice data science topics. But for tonight, I want to give you a well-rounded introduction into T-SQL and prepare you for a deep dive into SQL a little bit later.
Okay, yeah, so then we will just give you the stage here. So best of luck. And also for all our viewers, you're very welcome to post questions in the chat. And then after the session, we will have time allocated to do a Q&A session with JP. So just post it when you have anything to ask.
Okay, thank you very much for this opportunity and to all our viewers tonight. So let's jump right into this. So just a quick glance of the agenda. What we'll be covering tonight is the tools of trade. So how to get started, what platforms to use, and how to start writing your first query. Then we'll jump into an introduction to T-SQL to understand the basics of database objects and how to start working and looking at your data. And after that, we'll go into multiple data sets and the additional few things that you can take away from tonight's session. So let's get started with the big question in today's modern age of database technologies. Should I go cloud or should I go on-premise? So for the purpose of what we're trying to achieve here, this is you need to decide what's the right tool for the right job here for you. There's a lot of different cloud providers out there, AWS, Alibaba Cloud. I'm more focused in Azure because there's a lot of T-SQL specific offerings that Microsoft gives you in Azure, like SQL Database, Azure SQL Database, which is a singular database that you deploy in the cloud, or you can get some sort of managed instance, or you can just start up a virtual machine and install SQL and either bring your own licenses or buy your licenses in the cloud. Or if you're a little bit more conservative with your data and you want to be in full control and have it on your own site, depending on the organization you work for, you can have it on-premise, but then you are responsible for the managing of updates and hardware that does age, replacing everything every 5 years, and managing a lot more on that front to keep everything running smooth and going on. And so if you want to follow along in the future and want to start playing with the data, so in Azure, you can go and create a free subscription, get some free credits, and just start up a very basic SQL database, and you can start playing immediately for free. If you opt for the route to go and install it on your machine or on a server, I would highly recommend you start off with SQL Express, which is a completely free edition of SQL Server that you can install and use in a production environment. It has a lot of limitations, but the limitations for basic data wrangling, or there's almost no limitations for basic data wrangling. It just has a size limitation on how big a database can be. There's a couple of different editions that you can go on based on what your use case is. The Express is the basic free version. Web is made for web applications. Then you have the standard and enterprise, which you'll see more often in the enterprise or corporate environment. And then if you just want to play and investigate, the developer edition has all the bells and whistles of the enterprise edition, but it is completely free for use as long as you don't use it in any production workload. So you'll also notice that on every slide that I'll show you, on the bottom right-hand corner, there's a little tiny URL that I've added in there, and I'm not sure, but I do believe that the slide deck can be shared afterwards. You can go to that, and there's more information on these topics that I do cover that you can go and read up afterwards. So now we've installed a SQL Server either on our machine, or we've started up a Azure SQL database or managed instance. So what's the next steps? Now we want to start writing code. So now we need to have an IDE, a integrated development environment, where you can start writing your code into. And you can start off with command prompt. There's a SQL command that you can run there, or you can go and download any of these applications that I'm going to talk about now from Microsoft's side. All of them are completely free. The Microsoft Management Studio, SQL Server Management Studio, is probably the most well-known one out there and the most complete, well-rounded. Or you can, if you're more developer-focused, use Visual Studio Code. Or my recent favorite is the Azure Data Studio with all the fantastic plugins and snippets. It's quite powerful. So I've been working more and more in Azure Data Studio. So if you're going to install any of these, I would highly recommend starting off with Azure Data Studio. So on the screen there, you'll see on the right-hand side, there's a small screenshot that I took of Azure Data Studio and of the database and tables that I've created specifically for you for tonight's demonstration. So before we start writing code, I know I said let's jump in and start writing some code, let's take a moment to understand the basic concepts of what a database is and the different database objects. So I'm going to try and relate this as close as possible to Excel, because I found that that's a very nice way of relating all the different database objects. So if you were to think of what is a database, it is your Excel sheet, your Excel workbook. So you have all these different sheets, all these different columns and rows of data that you can have. And I've seen some organizations have massive Excel sheets of all their sales data going on and on for, and this is in its rawest form a database. So a table would then be considered a set of related data stored in on one sheet or in one table. So you can see if you can look on the right-hand side there of your screen, you'll see I went and I downloaded the famous cars data set from Kaggle. I've imported that in Excel just to give you an example of how to represent what a database is. And essentially what you're looking at here is the representation of a table. So you have all the different data nicely structured in rows and columns. So what is a column? A column is a set of particular or set of data of the same type. So you can see I've selected column A, which is essentially my make of the vehicles from the cars data set. You'll see all of the data in there relates to the make or manufacturer of this vehicles. And you can go on to column B, which is the aspirations, or column C, which is the number of doors the vehicle has, as shown in the diagram. Then the next form of data that you can have is a row, which is just a collection of the fields that makes up a record. So you'll see as represented in Excel as a row, or in the diagram here with my little red block. And then the smaller source of data you have in a database is as represented in Excel as a cell, is referred to as a field in the database world. So now that you have a basic understanding of how a database is structured, I think we are ready to start writing and looking at our first code samples. But just to keep you hanging for a little bit longer, there is a logical order of processing that SQL Server have. And I'll refer back to this in our next session and throughout the following examples. But in a nutshell, the SQL, the way you write SQL and the way SQL reads it is not the same. So you'll see that in some instances, I give columns different names, and I can reference them in with some of the statements, and some of the statements I can't reference them as is. That is due to the order that Microsoft SQL Server is reading my code. So let's start off by selecting some data. So what do we want to do? We want to select a certain amount of data, so some columns, some rows from our cars data set. So to start off with, we've written a small little query. That's what our code is called. It's a query, and I ask it, so select the top 15 records. So give me 15 records from my cars data set, or cars table that sits in the AI42 database. In there, I've asked it to return the make, the field type, aspirations, number of doors, body style, drive wheels, engine location, wheelbase, and price. But for the purposes of my analysis, I want to give them more practical, more user-friendly, readable names. And I prefer the camel case naming convention. So I went and I gave every column an alias of, so you can see make is make, field type, field underscore type, I renamed to field type, and so on and so forth. When I execute this, it will return 15 records for me with all of these columns that I've asked it. If I were to not want to return the wheelbase, I can remove this record and run it again, and it will return my data set without the data that I did not require. So it's generally considered a good practice to only return the data that you require. The reason for that is some data sets that you might work with in the future has millions, maybe billions of records. And you don't want, if you don't need all of the data, you don't want the additional performance overhead of returning all of the data that you might work with in the future. So it's a good practice to start early on in your journey to only return and work with the data that you're actually going to need for your models. So the next step is, so now we've decided how many records we want, we decided what columns we want to return, but we want to actually start filtering down on the data, because not all of it is relevant to what our end goal is. In this case, we could say our end goal is we want to build a model for all hatchback vehicles. So how do we go about that? In SQL, it's simple. At the very end of your query, or just after your from, you can specify the where statement, and you give it the column. So I've asked it the body style, and only return back the hatchback, or all the vehicles that is of a hatchback body style. So if you look at our little sample here at the bottom, you'll see that all of the data that got returned is of type hatchback, body style hatchback only. So then now we have our 10 records of the type, all the columns we wanted, and we filtered it back by only body style hatchback. But now I want to order my data or give it a specific ordering. And the specific ordering that I want here is to give me the wheelbase. I want the 10 largest hatchbacks based on their wheelbase. So what I've done here is there's an order by statement. Then I refer back to the wheelbase. So this is one of the examples where I spoke earlier about the order of execution, where I could specify wheel underscore base, but because the order by statement gets executed at the very last moment, I can refer to it as on its alias as well, because by that time SQL Server 2 understand what I'm talking about if I'm asking about the wheelbase. So I've asked it to give me the top 10 hatchbacks with the largest wheelbase in that ordering. So you can see the largest wheelbase is a Toyota hatchback, which is of type rear wheel drive. So now we're starting to put our data set together and getting the data in the order and format that we wanted. But now we will start. Now the next step is to start looking at our data as a whole. So we've now been looking at top 10 records, just sampling our data, looking at how we can query the data and understand what we're looking at. But at no point during what I've shown you so far, I can tell you how many Mazdas, hatchback Mazdas I have in my data set, or how many Toyota hatchbacks I have in my data set. So that's where grouping data comes into play. So I can group my data sets over one or more columns with different aggregations as well. What we've done here on this query example is I've asked SQL to select the make of the vehicle from our cars data table, but this time count for every instance of record that we come across. So do a count, and then also calculate the average price for this, and then go and group it by the make, and also order them. So the order in this case, I haven't specified ascending or descending. If you don't specify that, SQL Server automatically sorts it via ascending. And I've also just kept my filter for body style hatchback. So what this now does is this rolls up the entire data set into the make, the number of models, and the average price. So if you've worked in Excel with pivot tables, this is essentially what we've asked SQL now to do. So to group all of my data for me together and tell me, okay, so for Mazdas, I have 10 and the average price is around 10,000. Well, I'm assuming dollars. And for Nissan, you have 5 and the average price is about 14,500. So the power of grouping data is quite a lot. It's very powerful to go in there. And in the beginning, I said I'm going to focus a lot on T-SQL, because this is for Microsoft T-SQL, and there's a lot of different variants that you can focus on. And SQL is a querying language as a standard, and then all the manufacturers added their own little flavor onto it. So Microsoft T-SQL, they've added their own flavorings on it. PL SQL is Oracle, they've added their own flavors on it. So as SQL is an ANSI standard, so if you can write SQL code, you can probably write and understand in most of the different flavors there is. So now we've grouped our data, we've looked at filtering it, ordering it, and restricting or filtering down the data only as we need it. Then we're going to go into modifying the data a little bit. And there's two trains of thought here that you can follow. One is if the data is yours and you want to permanently make the change to the data, so modifying the data, you can go and write like at the bottom red block, I've written an update statement. So you might have noticed throughout the examples, Alfa Romero has a spelling mistake of, and I want to clean it up because here we refer to Alfa Romeo. And so I can either go and I can permanently make the change, and I can say in my table of cars in the database of AI42, go and set the make to Alfa Romeo where the make is currently Alfa Romero. So this is a permanent change. So everyone after you that will be querying this table will be getting the data in Alfa Romero as Alfa Romeo. If you can't go and change the data, you can just go and do like a temporary modification to only return the data in the way you want it to be returned for your model. And in the database and data world out there, this will be the most common way of working with data, because you won't be going, it's very rare that you'll go and update source systems and change the data and the underlying data to fit your narrative. So here you'll see I wrote a little select statement with a case statement in it where I say, well, case when the make is Alfa Romero, change it to Alfa Romeo. Otherwise, leave it as is and just mark it as my clean make for all the body style hatchbacks. And in the bottom, you'll see I've just added the second column called clean make. And there I've made the change on Alfa Romeo and from Alfa Romero. I hope everyone's still following along. Please feel free to post your comments as we go along, and I'll see if I can answer your questions as we go on. So now let's go a little bit deeper, and this is the part where most people get lost, but it's not very tricky. So when you're working with more than one data set, up until this point, we used one table. And most of the times you will be using more than one table to work with your data. So you'll have, as an example, an employee table with all the data set with all your employee information, and maybe a separate table with the employee salary information, because not all people are privy to see that information. So that's kept in a separate table with different permissions, so only select few people can see that. But now you want to build a report or do analysis on different career types for, there's a different report for the executives to show them what careers have the highest earning salaries in the organization. So now you have to join those two data sets together. So let's start off with like an inner join. So in most join cases, when you're using joins, you need some sort of join key. So in the example of the employee tables, you should have employee number in your employee table, and most likely would have employee number in your salary table. So those two will be correlated. So employee number one will have the salary of employee number one in the salary data set. So when I want to join these two data sets together, you can do an inner join in your data set, where I want to return all the data that matches between both data sets. So if I have 10 employees, but I only have 8 salary records, if I do an inner join, I'll only get back my 8 people which have a record in the employee table and have a record in the salary table. But if I just want to have a look at how many people is working for us and the salary information is the added benefit, then I can do a left join, where left join is I take everything from my first data set, the data set that I start off with in my from, and I enrich it with all the data coming in from my data set B. But if I don't have the data here, I still want to return this. So even though in the example I have 10 employees, but only 8 salary entries, I will get all 10 my employees. So essentially you'll get A and C data back. Right join is the exact mirror of that, where I decide to get all the data from my second data set and only enrich it with the data from where I have it from my first data set. And then you get a full outer join, which brings back the data from both data sets, regardless if they have a match between them or not. But how do you say? Wait, there's more. You also have different set theory methods of getting your data to join together or combined in SQL. And the way you can do that is with union, except, intersect, and union all statements. Now, what's the difference between all of them? So it's quite well documented, the different functions in set theory, but the union function in SQL essentially brings both data sets. Both data sets in this instance need to have the same columns. So you won't be using this method to combine the employee table with the salary data, but if you have two different employee tables, you can use this to join to create one big employee table, combining them together. So, and in this instance, if you union them together, union will combine both data sets together, but also remove all the duplicates for you and return a sorted data set. Where the union all will combine both data sets, but it does not care if there's duplicates. It will still return and retain the duplicate data. If you're looking at the intersect, it will only return the data where the two data sources match. So let's say I'm in both data sets, I will be returned. But if I was only in dataset A and not in dataset B, if I intersect the two together, I will not be returned because I'm not in both data sets. And except brings back all the data from, let's say, my dataset A, but remove all the data that's common between the two. And there's quite a few more that you can do. So let's look at an example of how to join multiple data sets together. So to join the multiple data sets together, there's the join function in SQL. And you can, as per the previous slides, inner join, left join, right join, full outer join. But there's also a shortcut if you just specify, if you just write the word join like I did here. This is essentially the same as an inner join. So what I'm doing in this example is I'm asking it, bring me back the top 10 records, specifying the columns. You'll see here I've specified columns from two different data sets. I've created a table called manufacturing details, which just contains the make and the manufacturing code of our cars that we are looking at. So now I want to bring in the manufacturing code into my data set because it will add some value to my next phase of my data cleaning and my data manipulation. To do that, so now I know I have a common key between both, and so that's the make. So I have a make column in both of these data sets. And for this scenario specifically, I need that manufacturing code. So if I have vehicles that do not have a manufacturing code, I do not want them to be returned. So what I'm doing now is I'm telling SQL to join these two data sets together for us. On the make, so I gave both of these tables an alias. So I said this table, call it MD, and the cars table, call it C. Then on my on statement, I asked SQL, okay, so look at table C, the make column, and make sure it's equal table MD, the make column as well. And joining these two together, then return the manufacturing code. But take note, now both tables have the make column in there. So now SQL wants me to specify from which table should it use the make column. If I do not specify the alias like I did here, C.make, which refers to using the cars table make column, it will return back an error for us, which could be a little bit confusing. What I've also done here is something that we'll dive a little bit deeper into in our next session, is I'm ordering my data by new ID. So this is a pseudo-random key that SQL generates. So what I'm telling it, just return 10 random records for me. Because if you don't specify order by when you have a top, it does assume some order depending on how you're indexing and how your data was stored. But at this moment, I'm asking it return 10 random records for us, so that we can just have a look at how the data sample looks like. I see there's a question that's asked, can I write T-SQL queries inside of Jupyter Notebooks? And you can, but it's a little bit more complicated than that. So you can write SQL statements in Jupyter Notebooks if you connect it to some sort of Spark cluster. So then you write PySpark SQL. You also have the ability in Azure Data Studio to create T-SQL notebooks. And also in Azure Data Studio, link that to a Python engine as well for the following modules. So in short, yes, you can, but it's not Jupyter Notebooks, it's more Azure Data Studio notebooks, but it follows the same flow and it looks very similar. Okay. So now going just a little bit deeper into the options we have that we can do in SQL is one of my favorite functions is to create stored procedures. So stored procedures is, by the dictionary definition, an encapsulated set of T-SQL commands that can be run repeatedly. But that's quite a mouthful, essentially. And all that means is it's like a little container where you put all of your code in, and you can pass parameters through so that you can run this over and over again and obtain the same result. So in the example I've created here on my right-hand side, I created a stored procedure saying create new manufacturing code. And I have to pass it the make of the vehicle through when I execute this. And the first thing that I want to do is I want to check in my manufacturing table. If I have that make already in my manufacturing table, generate a new manufacturing code for me. Because in this business case, that's what I needed to do. If I do not have that make of vehicle in my data set, then create a new record for me with a new manufacturing code. And all of this code will use in practical examples in our next session in a much deeper and way to understand how this all fits together. And then after I've performed my data manipulation or data alteration operation, I just want to return the top 10 records of that make if there is any. So just return that back as a data set, just to give myself some reassurance that what I've done actually did work and the data that I'm looking at is what I was expecting to get back. Now, views. So this is probably one of a very powerful tool, especially if you have repeated workloads that you need to perform to your data sets from a existing system. So if you get a table that there's the same alterations that you want to make to it every month on month, but you're not allowed to change the underlying data. To make your life easier for yourself, you can create a view, which is essentially a virtual table with predefined logic already defined inside of it. So as an example, I've created an executive overview data set where I said, select my manufacturing code. So already join these two tables together so that I don't have to join them again when I'm referring to this data set. Return my manufacturing code, my field type, and I want the number of doors returned back as numeric because I feel this might be significant for my model. So to return the number of doors as numerics. And if it doesn't fit into my little bucket of 2 or 4 doors, just bring back a null, which is just the absence of a value. And so once you've created this view, you only have to do this once. So from that point forward, I can create, this is now seen in SQL as a table. So if you query this data, this virtual table, I ask it return top 10 records from this table where body style, so I've also returned body style isn't sedan and hatchback. There you can see it changed my number of doors already for me to numeric, and it returned the other data as and how I requested it to be. So then let's jump now. Let's talk a little bit about the operations that I showed earlier in the stored proc on how to alter your data. So what I'm showing here is CRUD, referred to as CRUD operations. It is create, read, update, and delete. So the read part we've covered now deeply. It's or in depth is all the select statements, and then the create, update, and delete. We're going to go through an example of how to do that in your data right now. So if you want to insert or create more data, SQL Server has the insert into statement. So what you would do is you say insert into my table. You specify the columns you want to add the data into, and you specify what the values need to be correlated to those columns. So you'll see the make is Ford. The body type is of pickup, and the number of cylinders is 8. That's the data that I want to insert. If I find data that I want to change, I can go and I can say update my cars table, set the number of cylinders to 8, where the make is of Ford and the number of cylinders is 6. So you'll first do a select statement to ensure that you have all the correct where predicates. So I also saw a comment earlier, someone said, please remember this where clause. So when you're updating data, if you do not have a where clause, if you just run update cars, set number of cylinders to 8, it will update every record in your data set where the number of cylinders 8, which is quite fun to sort out afterwards. And then afterwards, you realized, after we've gone through all of this, we realized, okay, we actually don't need Ford in our data set because it doesn't add value to, or not going to add value to whatever we're trying to prove. So you can go and tell SQL delete from the cars table where the make is Ford. The key is, again, the where clause, because if you don't specify the where clause, if you just say delete from cars, it will go and delete every single record. So yeah, I have asked it to delete when make is Ford. So there could be 1 record, it could be 0, or there could be 100, and it will go and delete all the records that is of type of my make Ford. Now to have a little look about our in windowed functions. So there's a lot of very well presented videos out there on windowed functions, because it's a little bit more complicated than just a quick slideshow and a quick explanation. But essentially what you want to do with windowed functions is you create artificial windows on your data and perform specific aggregation. So you can perform any aggregation, all the way from summing, average, standard deviation on over your windows and window functions. If you look at our example query here, I've created I've asked SQL to give me a rank over, so the partition by, I'm creating a window by over the make. So I'm telling it, just look at the Alfa Romeo and rank them ordered by the city miles per gallon descending. So what I'm doing here is the first 2 convertibles is ranked 1 and 1 because they have the exact same. And then the next Alfa Romeo hatchback is ranked number 3 because that the rank is the +1 on the number before it, or all the ones before it. And then my second window is, I ask it, because I've specified my window on make, is looking at Audi, and same order it by my city miles per gallon descending. And you'll see there that the first one is 1, then I have 2, 2, 2, so all 3 of these is the same. And then the next one is ranked 5th, because it's 1, 2, 3, 4, 5, and 6th and 7th. So that is the rank function. There's also another function that you could use in the windowed functions called dense rank, and this returns, instead of skipping one, it just goes to the next one, but it does repeat. So you'll see I've asked the exact same question, used the same window, the same order by, so determining what comes first in my order. But this time I've told it to use a dense rank, and you'll see the difference here is my first is still 1, 1, but the third place is now no longer shared. It is now it's now in second place. When the rank, it was third place. And if you look at Audi, it's 1, 2, 2, 2, 2, 3, 4, 5. So depending on how you want your data outcome to be represented, there's a lot of different functions that we can use. So the last one that I want to show is just a row number. This is something that I probably use on a daily basis, because you can also use this to remove duplicates on your data, because not all duplicates is considered true duplicates. So if you have a specific logic to understand what is duplicate data, row numbers is probably one of your most powerful tools to remove these duplicates. And as you can see here is I've asked it to return the same question, create a window over the make, and order by city miles per gallon, but descending, and add a row number to this. Here you can see what it's doing is the first one is 1, the second one, even though it's the same city miles per gallon of 21, this is now 2. So in my case, I would have considered this as a true duplicate. So that's easier to remove then. Or if I just want to return the car with the best or the worst city miles per gallon, so the best, and I don't want to return 2 of them, I just need 1 record for each make. This is how I would do that. Okay. Then another tool that is very, very powerful if you've come to grasp with it is common table expressions, or CTEs. So this is, in layman's terms, creating a view on your data live without storing the view permanently or that code of the view permanently. A common table or expression also has the ability to refer to itself, so recursive CTEs, but that is out of scope for this session right now. So you'll see a CTE, what you can define it as per this example, is you start off with the keyword with, and then you name it. So you can name it anything. I just got used to calling it CTE, so mentally that I know I'm working with a CTE when I get to my next parts of my code. In here, I can perform all of my data manipulation that I'm looking at. So yeah, I'm grouping on the manufacturing code and body style, and I'm getting the average doors for them. And then I'm writing a select the distinct body style from this temporary view that I've created, temporary virtual data set that I've created, where my average doors is greater or equal to 4. So it returns sedan and wagon. So no hatchback got returned because the average number of doors for hatchbacks is lower than 4. And then looking at pivot versus unpivot. So this is one of those SQL functions that till this day I have to go and look at the documentation to get the syntax right every single time. But essentially what it does is every time so far we've been looking at the data is you'll see your manufacturing code, body style, for example, and the average number of doors. That's what we did in the previous example. But now I want to separate my manufacturing codes across, and I want to pivot, cross-tab my data to show for this manufacturer, what's the average number of doors per hatchback, what's the average number of doors per sedan, and the same for the next one as on. And if there's no sedan for that manufacturer, just return a null record. So that you refer to as a pivot table in SQL. So that takes form of you write the keyword, the function pivot, tell it what you want it to do with your average number of doors. In this case, I've asked SQL to average it because it doesn't make sense to sum the number of doors for my body style, and then I give it the values that it needs to use as my columns and call this a pivot. So now I transformed this data set here into a pivot where I have the average per hatchback and sedan that I can look at in this instance. Now, this is something you could that would prove to be very useful when building building models in data science, because it makes sense for you to feature engineer your data much easier and pulling out all the data that might be of relevance to your data set. There's also an unpivot statement that traverses this action that would turn this data set back into what we had it before, if you require it like that. And then there is analytical aggregation. So this will cover in much more depth in our next session, but just know there is ranking, there's cumulative distance, there's lagging and leading functions. You can also, in SQL, there's standard deviation, average. There's ways to calculate your z-scores, your z-scores. So you have a lot of functionality and power that you can start off to prepare your data with. Once you become very familiar with the T-SQL language, it does become very easy to do your data manipulation in there. So I prefer, before I start building any models or data analysis in, so I prefer to work in Python. So before I start doing all of that analysis, I prepare my data in SQL Server because it just works a little bit better for me, and it's I'm more used to the structure of the language. And it's built to work with large data sets. So if you're interested in going the next week or two and having a look at different external resources and getting to grips with SQL Server a little bit faster, I've listed a few links on the screen that you can go to. The very first one is from the Redgate University, written by Kendra Little, MVP, and it's just 3 hour session, very good introduction session. The three is more full structured courses, which will take a little longer, but you will get a good grasp of what SQL Server T-SQL and SQL Server has to offer. Okay, let's hand over to questions. I saw a few questions coming in.
Yes.
We have just seen an awesome session again, this time from JP. So thank you a lot. We just brought ourselves back online so we can get the questions for you. So because we have a lot actually, so it's pretty good. Some of them you have answered already during the session. So let's see. Okay,
Yeah,
do you?
so,
Or yeah.
Yeah, so let's first start here with the question. 1 moment there.
So, is it possible to import data directly from Transact SQL commands without using SQL Server integration services?
There's many different ways. Let me just repeat it. Is it possible to import data directly from T-SQL commands without using SQL Server integration services? Yes, it is. There is a number of different ways that you can achieve this. One is there's a function in SQL Server called open row sets, where you temporarily can create linked servers to your files. And it also depends on which technology you're using. So if you're in Azure or using SQL Server with any Java libraries installed, you have the ability to query CSVs, text files, and Parquet files directly from within your T-SQL code. It's a little bit more in depth, and it's a little bit more complicated to set up. But once you have it set up, it is so awesome to work with. It's fast. The Polybase engine does work with the Hadoop interfaces and Hadoop storage systems very, very well.
Okay.
Hope that answers the
Thank you.
question.
Then we have a question here from Ashish. He says, what is the difference between SQL and T-SQL?
So SQL refers to the ANSI standard of the language. So there's a standard set out of how SQL, the sequential query language, needs to be written, and how all the manufacturers need to follow it so that not everyone goes off on their own tangent and changes everything. T-SQL is Microsoft's flavor on top of that, so that it conforms to the ANSI standard, but then they've added their own functionality on top of that. It's not in all the different versions of SQL. For example, like the analytical functions. Not all of the analytical functions is in the SQL standard, but they are part of T-SQL.
Okay.
That was a good explanation.
Can I write?
Yeah, go ahead.
Can I write T-SQL queries inside of Jupyter Notebooks on the fly? So I think I touched on this a little bit earlier, but so the answer is yes and no. So you can write SQL queries in Jupyter Notebooks if you are connected to some sort of Spark environment, because then you have what's called magic commands. You just create a temporary table in Spark from your data frame, and then you can query it using normal SQL language and manipulate it as well.
Yeah.
But directly from Jupyter Notebooks, which I presume you should have installed on your laptop or your local machine. If you don't have that environment, the answer is no. You can create notebooks in Azure Data Studio, but then you can't jump between SQL and Python in the same notebook. You'll have to create two different notebooks, one for Python and one for SQL.
Yeah. Yeah, those magic comments are like, these percentages and then
yes.
SQL and stuff.
You just say percentage SQL and then you start writing
Yes.
SQL. And that's what I normally do when I can't figure out how to alter the data in Python. You just move it into a temporary table, magic SQL, change it into SQL, and then go back into Python.
Yeah, that's what I'm doing all the time on Databricks. Like
yes.
Well, my notebook is in Python, but I'm writing in Scala sometimes in SQL. It depends on what I'm doing. So,
whatever I understand at that moment,
yes.
how to do with the data. Yes.
And next question is from Pradeep, who says, how is T-SQL beneficial with respect to data science projects?
So I think we covered a little bit on this on all the previous questions, but you can go without SQL. You can go get your data in a flat file format, pull it into your Python or Spark or Databricks environment and manipulate it and do all your model building, all your data analysis, all of that directly off of this. The power you have with SQL, especially in T-SQL, is you have a engine behind it that's built for the data manipulation, and it's built for storing and returning data. And most organizations that I've worked with in my life has some sort of database engine where they store these data in. And if you have the ability to work with the data and prepare it before you even get to your local machine, which most likely the server where this data sits on is a couple of $100,000s, which has the processing power to process this big amount of data, where if you try to run that on your local machine, you might have to go for more than one cup of coffee before you get anything back. It has its place, and especially the more comfortable you get with the language, the more, like you've said, jump between languages and do what you needed to do at that moment.
Mm-hmm.
Thank you.
And then a question from Steven. He says, like Panda SQL, is there any package for T-SQL too? Or Panda SQL will work too?
So with Panda SQL and Python, if I understand the question correct with my background of how I've been using it, so Panda SQL is just use the SQL Alchemy engine to connect to any SQL engine below it. So that is SQL queries that you actually execute against the database engine, if I understand this correctly.
Okay, and next question is from Øyvind. He says, can you comment a little on SQL Server versus Postgres versus MySQL and similar pros and cons and T-SQL compatibility?
Okay, so you're talking to a massive Microsoft fanboy here. So I'm trying not to be biased, but PostgreSQL and MySQL is free and open source database engines, where Microsoft SQL Server is a paid for use service or server, but you get what you pay for. That is the instance. So essentially, MySQL is a great engine, and probably there's so many websites that you visit daily runs on MySQL because it's so lightweight, it's small, and it's not resource intensive. But it does not handle big data on its own. It really starts to struggle when you hit a couple of gigs of data. Postgres is built far better, and if I recall correctly, it's built by the same people that built MySQL. It just went and improved on that engine. And for Postgres, it's much better and it's much more aligned to enterprise grade. But that comes down to your preference on what you want to pay for and what you want to use. I personally work every day in Microsoft SQL Server and every now and again in Postgres. So without being biased, I prefer working in SQL Server because it has it's just a little bit more powerful and you get what you pay for. On the part for T-SQL compatibility, T-SQL is specific to SQL Server. But if you understand T-SQL, it's very easy to get to grips with SQL. So you can write your exact same query 9 out of the 10 times against Postgres and MySQL, and you'll get the exact same output. In some instances, the differences between T-SQL and the ANSI SQL, as it's referred to, is you'll see in all the examples I had a top statement in. The standard in SQL is to have a statement not at the top of your statement that says top 10 records. At the very end, you have a limit 10, and it returns then 10. So there's subtle changes, but it's a very, very easy change to make once you jump between the different variations of SQL.
Good.
Thank you. Which is better for processing, CTs or temp tables?
Like any developer or data analyst or data engineer would tell you, it depends. But depending on what data you're processing and how you're processing it, I prefer CTEs because it has less overhead on your actual server. So what temp tables refer to is in Microsoft SQL, you have the ability to create what's called a hash table. So you insert into a table that only exists for the moment that you are in your current session, in your current query. So you can do some alterations, create the temporary table, and then refer back to it. Nice thing about the temporary table is you can create specific indexing on it and a lot more rules than you can do in CTEs. However, temp tables is stored on disk, where CTEs are predominantly, but not mostly, stored in memory. So if it's not a lot of data that you're working with, the CTE will outperform a temp table anytime.
Ooh, that's a good information. Thank you. Well, we had a lot of questions. Are you still ready for all these questions? So the next one is NoSQL also used by data scientists?
I can't comment for all data scientists, and I'm more specifically a data engineer, but I know developers love NoSQL, and NoSQL stands for not only SQL. It's the ability to store unstructured data, where SQL you store structured data in all the examples. So with NoSQL there's there is no structure. I used to refer to it before a couple of years ago as the lazy way for developers to just change their code because they don't have to go and change the underlying database for to capture the new data fields that they are requiring. However, yes, I do think that in today's age of technology and information, NoSQL becomes more and more relevant, especially because of the document stores and, let's say, tracking data. So any data sources that has hundreds of thousands of entries every second is much more easily stored in NoSQL, and then you can go and attempt and aggregate and pull that out and clean it up for your project. Or you can create a structure from your NoSQL data, pull it into a structured environment, and then start with your analysis. And that's how I would approach it. But I think there's people that's more qualified to answer that question a little bit better.
Yeah, I can just say that yes, NoSQL is used by many data scientists, and especially because many companies at some point decided that NoSQL is really good for their specific data solutions. So yes, it is used very often. Yep. Let's go to our next question. That is yes,
sorry.
thank you, Pradeep. So our next question, this is one of my favorites. Is it really important to learn T-SQL to be a data scientist?
My opinion, yes. So this is my own opinion, but absolutely. You can get by without it, but you will spend so much more time on getting to the result and the outcome than what you should be. And a data scientist, in my mind, is someone pretty senior that has industry expertise, data expertise, and expertise with working with customers and clients. So you don't always have 3 years to build a solution and to present your findings. And learning T-SQL will just speed up that process of exploratory analysis and even feature engineering so much that it is worth spending some time to get to grips to the T-SQL, to understand T-SQL, because it will help you going forward a lot.
Yes, I totally agree with you. So many people, many clients we have worked with, most of them are still having data in SQL too. Like that's just normal to use that.
Yes.
So yeah. Okay, we have another awesome question, I think. What is the difference between data engineering and data science?
That is a fun one. So
Yes.
with all these new buzzwords that pop out every couple of days in the technology space, data engineering, in a nutshell, is the process of, or the person that's responsible for the process of the data flow, the data pipelines. So moving data from source A to source B, altering, cleaning, updating the data, ensuring that the data is in a good enough state for your data scientist. So data scientists are by definition can do what the data engineer does, but generally more specialized towards the mathematics, the statistics, and the model building. So the data engineer and the data scientist would normally work very closely together. So the data engineer would be responsible for consistently delivering the data to the data scientist, and you'll get your data scientist in to build the models and to evaluate all the models and then request for more or less data there. But maybe you guys can add something on that.
I would cut it a bit more into pieces because you already mentioned that is modeling and do some machine learning and stuff. I would cut that up as well because data scientists and AI engineers. that part when we are talking about that, because modeling is it really requires a bit more than just data science and statistics, and that is where mathematics comes in as well. Yes, but also a lot of strategy when building AI. So that's yeah.
I would also add that I think one critical competence for the data engineer is actually to be able to put things out in production. Whereas a lot of times the data scientists, they're good at modeling and exploring and proposing different types of solutions. But a lot of times it's more up to the data engineer to actually get it productized. But there are always, these two roles can flow into each other, and sometimes you can find someone who is strong in one area and maybe knows a little bit less in the other area. But usually, data scientists and data engineers have quite a lot of overlapping competence.
That's true. Mm-hmm.
Yeah. So I think we actually reached our final question here.
So if we use T-SQL to extract and transform our data, so most of the load will be handled in SQL Server side?
That is 100% correct. And like I said previously, so generally speaking, your SQL Server will be much more powerful, optimized for storage, compute, and all that. So if you do your extract, and you don't need to do all of your transform, because there's a lot of transformations that is far better suited in Python. So this is the scenario going back to the right tool for the right job. So I used to refer to, if you're a hammer, all of a sudden everything becomes a nail. So to give you an example, so one of the things that I do quite often is string distance calculations. And so when you algorithms like Levinstein, Jared Winkler, there's a lot of those algorithms to match different strings fuzzy to each other. Now, in that instance, SQL Server needs to go through your data row by row to do that comparison. And as soon as you need to do row by row operations in SQL, it slows down significantly, because it was never built to be able to do that. Where your Python or R or whatever language you do your rest of your analysis is much more suited to work with row by row data, and especially because it pulls it all into memory. So to give an example, I can do majority of my data transformations I do in SQL, but when I get to like string distance calculations, I pull that directly into my Databricks environment and do it there, because I have massive SQL servers, and even that big service takes like 40 minutes to perform some of my string manipulation or string distance calculations. When Databricks, because it's so clustered, a clustered environment, I can do it in 2 minutes. So that's quite a big shift in time. And in this corporate environment, time is money. So the quicker you do it, the better. I can get more coffee.
Yeah. Yes. Thank you a lot for all the questions, guys. I would like to just wrap it up, because I can see that that we are a tiny bit over time. So let me just let us just say a great thank you to JP for this awesome sessions. And guys, don't worry, you can just take your questions with you for now. We will note them as well for ourselves, and we will answer them later. And I think JP will probably come back to us with another session at some point, with a bit deeper session about SQL, and then we can continue this conversation as well. And with that, I want to say a big thank you again, JP, for the content, and for that you joined us and you shared your knowledge with us. And yes, thanks, thank you. You rock, right? So, yes, and I thank you a lot for the attendees as well for joining us tonight. And it was great to read all your questions. We will note them down and get it answered as soon as possible.
Thank you so much for the opportunity.
Yes. And then for people interested in knowing more about our session, just join our meetup page, and also subscribe to our YouTube channel so you don't miss anything. So next sessions will be in 2 weeks, and then we will talk about Python, so you're very welcome to join that session. So with that, thank you so much to all of you who attended, and looking forward to seeing you in our next session.
Bye.
Bye-bye.